Binomial distribution. So binomial distribution is a discrete probability distribution. So before going to discuss about binomial distribution, binomial experiment, an experiment for which satisfies the conditions, four conditions are called binomial experiment. An experiment for which conditions 1 to 4, so these are the conditions 1 to 4 satisfied is called binomial distribution. Now the experiment consists of a sequence of n smaller experiments called trials. See, for example, tossing a coin n times. So each tossing is a trial. An experiment consists of a sequence of n smaller experiments, where n is fixed in advance of the experiment. Now, the second condition, each trial can result in one of the same two possible outcomes, say success and failure. So, if I let getting head is the success, getting head is the success is defined as getting head is the success. So, if I toss a coin, the possible outcomes are head or tail. So, the sample space consists of two elements, head and tail. So if I get head, it is success. If I get tail, it is a failure. Now each trial can result in one of the same two possible outcomes. Third condition, the trial are independent. Tossing a coin 10 times. So each trial are independent. And the probability of the last condition, probability of success is a constant from trial to trial. From trial to trial. So in this example, getting head is the success. So the probability of success is equal to 1 by 2 for each trial. So one should toss the coin 10 times. Each case, the probability of getting head is equal to 1 by 2. So probability of success is constant from trial to trial. So those experiment satisfies these four conditions are called a binomial experiment. Binomial experiment. Now the binomial random variable. The binomial random variable capital X associated with binomial experiment consisting of n trials is defined as capital X, the number of S among the n trials. That means number of success among the n trials. Total number of success in n trials is equal to the random variable X, capital X. Now, toss a coin 3 times. N is equal to 3. N equal to 3. Then there are 8 possibilities. Success, first one, a success, that means getting head. Second toss, head. Third toss, head. That means success, success, success. Next one, success, success, failure. Head, head, tail. Then success, failure, success. Failure, success, success. Then failure, failure, success, failure, success, failure, success, failure, failure. Then 1, 2, 3, 4, 5, 6, 7. Last one, failure, failure, failure. 8 possibilities. So this is the sample space. Now, from the definition of capital X, that means number of success. So since there is three success, capital X of SSS is equal to 3, capital X of SFS is equal to 2, capital X of failure, failure, failure is equal to 0. Since there is no success. As you can see here, X of SSF is equal to 2, X of SFF is equal to 1, and so on. So possible values of X in an n-child experiment are X equal to 0, 1, 2, 3, up to n. So these are the possible values. So in this case, in this particular case, X can choose the value 0, 1, that means 0 success, 2 success, 3 success, 1 success. Possibilities are 0, 1, 2, 3. For n childs, 0, 1, 2, 3, up to n. We often write capital X equal to binomial capital B I n of B of np, or simply capital B of np. Binomial distribution with n is equal to number of childs is equal to n, and p is equal to probability of success. P equal to probability of. Now, because of the PMF, probability mass function or probability distribution function, a binomial random variable capital X depends on the two parameters: number of trials n, probability of success p. We denote binomial of the probability distribution. We denote the probability distribution mass function as binomial of x n p, x n p, or probability of. So this is nothing but probability of the random variable x, the binomial random variable capital X, choose the value x with number of trials n, number of trials equal to n, and the probability of success equal to p. B, x, and p. Now consider the case n is equal to 4. Tossing coin n times. Tossing a coin n times. So the possibilities of outcomes, the possible outcomes are success, 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 success. For success, then success, 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 failure, and success, success, failure, success, goes on like that up to failure, 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 failure. So total number of outcomes are 16. 16 outcomes, and x is equal to 4. Number of capital X, x is equal to number of success, number of success. The random variable x is equal to number of success. Now first case, success is equal to 4. Second case, success 3 success, again 3 success, 2 success, 3 success, 2 success, etc. And the last one, failure, 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 0 success. Now each with probabilities are shown in this table. First one, 4 success, 4 success, and the probability of success equal to p. So for example, probability of success, success, failure, success is equal to P of S into P of S into P of F into P of S. That is probability of first success into probability of second one into probability of failure into probability of success. Since each trials are independent trials, probability of success equal to P, probability of success again P, and probability of failure is equal to 1 minus P, or simply Q. And the last one, probability of success equal to P. The total probability of the random variable X, choose the value SSFS, is equal to P cube into 1 minus P. Tossing a coin 4 times. Now the question is, what is the probability of getting first trial as success, second trial as success, third trial as failure, last trial as success? Now what is the probability of getting this one? Probability of getting success, success, failure, success, and which is equal to p cube into 1 minus p. So in this particular case, the probability of success equal to 1 by 2, since we are tossing a coin. So for different type of experiment, the probability of success may change. For example, throwing a die, the probability of success. Suppose I am defining as getting one is the success. Throwing a die, getting one is the success. So probability of success is equal to p is equal to 1 by 6. So p is equal to 1 by 6. So in this case, probability of success equal to, so for tossing a coin, the probability of success equal to 1 by 2. So as you can see, probability of the random variable takes the value s is equal to p raised to 4. That is p into p into p into p 4 times. That is p raised to 4. SSSF is equal to p cube into 1 minus p. SSFS is equal to p cube into 1 minus p. Goes on like that up to last one, failure, 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 failure. That means 1 minus p 4 times. 1 minus p the whole raised to 4. So these are the probabilities of each uh, outcomes. Now, the question is, out of 4 trials, what is the probability of getting 3 success? What is the probability of getting 3 success? That is, the question is to find binomial of 3 x equal to 3 for p. P is equal to uh, p is equal to for tossing a coin, p is equal to 1 by 2 in particular. So now probability of 3 success. So these are the probabilities: success, 3 success, and another one 3 success. SSFS, first one, second one, and third one. These are 3 successes. Another one, yes, this one, 3 success. Then there's not. So 4, 3 successes. The total number of probability binomial of 3 for p is equal to probability of FSSS, probability of SFSS, this one, probability of SSFS plus probability of SSSF is equal to 4 into p cube into 1 minus p. So p cube into 1 minus p 4 times. Similarly, you can able to find the probabilities of binomial of 2 success out of 4 trials with probability of success p, small p. So in this case, which is equal to 2 success, 1, 2, 3, 4, 5, 6. So 6 into, now probability of 2 success equal to p square into 1 minus p the whole square. P square into 1 minus p whole square. So this is the probability of binomial of probability of getting 2 success, or binomial of 2 for p. So in general, probability of getting x success out of n trials is equal to BNP, denoted by BXNP, BXNP, which is equal to NCX P raised to X Q raised to N minus X. NCX P raised to X 1 minus P
whole raised to n minus x. So this is the probability of x success out of n trials with probability of success equal to p. Ncx p raised to x 1 minus p the whole raised to n minus x, or equal to q raised to n minus x. 1 minus p is equal to probability of failure. This is called the binomial distribution function, or binomial probability distribution function of a binomial distribution function. Binomial distribution. PMF of binomial distribution. NCx p raised to x q raised to n minus x. X is equal to x can choose 0, 1, 2, 3 up to n. Now another example. So for a each of 6 randomly selected cola drinkers is given a glass containing cola capital S and one containing cola capital F. That means capital S is the success, capital F is the failure. So the glasses are identically in appearance except for a collar in the bottom to identify the collar. Suppose there is actually no tendency among cola drinkers to prefer one cola to the others. That means they are independent. Then P is equal to probability of success equal to 0.5 or 1 by 2. There are two glasses, each 6 randomly selected cola drinkers. Okay, so n is equal to 6. N equal to 6. Probability of success equal to 1 by 2. Capital X, the random variable X is equal to number of among the 6 who prefers S. Number of persons among the 6 persons who prefer success. Capital X, binomial of NP. N is equal to 6, P equal to 1 by 2. 6 comma 1 by 2. So the probability that at least 3 prefers S is probability that at least 3 prefer success. That means probability of X greater than or equal to 3. Probability of X greater than or equal to 3. At least 3 prefers success, or equal to P of 3 plus P of 4 plus P of 5 plus P of 6. P of 3 plus P of 4 plus P of 5 plus P of 6. At least 3 prefers success. Or simply probability of X, the random variable X takes the value 3 plus probability of the random variable X takes the value 4 plus probability of the random variable X takes the value 5 plus probability of the random variable X takes the value 6. So which is equal to summation uh, X equal to 3 to 6 binomial of X. N is equal to 6, P is equal to 1 by 2 or 0.5. X varying from 3 to 3 to 6, 3, 4, 5, 6, which is equal to binomial of 3, 6, 1 by 2 plus binomial of 4, 6, 1 by 2 plus binomial of 5, 6, 1 by 2 plus binomial of 6, 6, 1 by 2, which is equal to using NCX, P raised to X, Q raised to 1 minus X. So here P is equal to 1 by 2, Q equal to 1 minus P, which is equal to 1 minus 1 by 2 equal to 1 by 2. Q equal to 1 by 2, P is equal to 1 by 2. Now, sum of all probability is equal to 6C3 1 by 2 whole raised to NCX P raised to X equal to 3. Q raised to Q or 1 minus P equal to 1 by 2. 1 by 2 raised to N minus X. N equal to 6. 6 minus 3. Again 3. Plus. So this is binomial of 3, 6, 1 by 2. Plus binomial of 4, 6, 1 by 2. That is 6 C4 1 by 2 the whole raised to 4 plus or into 1 by 2 the whole raised to n minus x. 4 minus 6 equal to 2 plus. So this is also time. The third term binomial of 5, 6, 1 by 2 equal to 6 C5 1 by 2 whole raised to 5 1 by 2 whole raised to ncx p raised to x q raised to n minus x whole raised to 1 plus the last term 6C4 6C6 6C6 1 by 2 all raised to 6 into q raised to n minus x. N equal to 6, x equal to 6. 6 minus 6, 0. So calculate the values for 6C3 into 1 by 2 the whole cube into 1 by 2 whole cube or 6C3 into 1 by 2 the whole raised to 6 plus 6C4 into 1 by 2 the whole raised to 6 plus 6C5 into 1 by 2 the whole raised to 6 plus 6C6 into 1 by 2 the whole raised to 6. So 6C3 plus 6C4 plus 6C5 plus 6C6 into 1 by 2 the whole raised to 6 into 1 by 2 the whole raised to 6. So the final answer is equal to 0.656. 0.656. So 6C3 plus 6C4 plus 6C5 plus 666 into 1 by 6 the whole 1 by 2 the whole raised to 6. 1 by 2 the whole raised to 6 take as a common factor from each term. You get the final answer as 0.656. Another one, find the probability of at most one prefer is. At most one prefer sexes. That is, the question is to find probability of x less than or equal to at least one prefer sexes. Probability of x less than or equal to 1 equal to probability of 0 plus probability of 1, which is equal to binomial of 1 np, n equal to 6, p is equal to 1 by 2 plus binomial of p of 0 x equal to 0, p of 1 x equal to 1, 1 6 1 by. Now calculate the value separately by using NCX, p raised to x, q raised to n minus x, which is equal to 6c0 1 by 2 whole raised to 6 plus 6c1 into 1 by 2 the whole raised to 6, which is equal to 1 by 2 whole raised to 6 into 6c0 plus 6c1. And the final answer is equal to 0.109. 0.109.